Hello everyone, welcome back to the channel. In the last video, we talked about how PySpark work with actions and transformation. Now in this video, we are going to dive deeper in the inner workings of transformations. Okay, I have already shown you that actions result in creating the jobs. Okay, while executing our code, whenever we perform any action function, it will return in creating the job, right? Now in this video we will move ahead and we will first of all see what is step-by-step plan which PySpark follow to carry out our transformations and actions. Okay, so let's say this is the code which we have written. Now the step-by-step plan, what the first step in this plan, when Spark actually start executing this code, it will create the jobs. It can have one job or it can have multiple job. Let's say I will create two jobs. We can have more than one job as well. Okay, now each job will be divided into stages. Now a job can have one stage or it can have more than one stage. Okay, so this job 0 has two stages, but job 1 has one stage only. Okay, so each job will have at least one stage, always remember. Okay, it will always have at least one stage, but it can have more than one stages as well. Okay, which we have shown in for job 0. Now the stages can be divided into task. A stage can have one task or it can have more than one task, but it will always have at least one task. Okay, so a stage will always have at least one task. A job will always have at least one stage. Okay, so job one stage at least, stage one task at least, always remember this. Okay, so this is how PySpark follow or create step-by-step plan to carry out the transformations and actions we have specified in our code. Now I think it is clear. Now we already told or we have seen these jobs are the result of actions. In the similar way, these stages are result of transformations. Okay, these are result of transformations. For task, we'll look into the subsequent videos. So let's continue with the transformation first. Okay, so in Spark, the transformations are classified into two categories. One is narrow and the other one is wide transformation. Now this narrow and the wide transformation classification has been done based on the processing of data. Okay, so obviously the question comes in our mind, right? On what basis we can say these functions are narrow transformation functions and these functions are wider transformation functions, right? So it depends on the number of, basically it depends on the flow of data, you can say. Okay, just give me 1 minute, let me plug in the charger. Yes, so it will depends on the data flow or data processing during the execution. Processing of data during execution. Okay, now let's start trying let's start understand the processing of data. Okay, but before that we need to keep one thing in our mind. Okay, whenever we start execution, right, the data will always be residing inside the partitions. Okay, now it's up to the Spark. It can create one partition or it can create multiple partition to store the data and perform the functions on top of it. Okay, so let's say you have this data with you. Okay, now this is the file. Okay, PySpark started reading this file based on the code you have written, and it creates two partitions out of it, p1, p2. This is our data frame which has two partitions inside it. Okay, and these partitions has the data inside it, right? Now I will perform one function on top of it, one transformation on top of these data frame. So that function will first hit, that function will hit on both the partitions, and it will create another partition out of it. Let's say p3 and p4. But for this function, I don't have to interact, or the data doesn't need any interaction between the partitions. Okay, let's say I said select function, okay, where I want to select few columns. So it will perform this select operation on this data first of all, and it will result in one output data frame. Okay, df2, and same goes for this partition as well. It will create another partition with new set of data after this function. So one input data frame or one input partition result in one output partition. Okay, and it doesn't need any communication between the partition. So there is no communication between these partitions. Okay, this is one flow of data where the functions will be applied onto the partitions, and it doesn't need any communication between different partitions. There is no coordination required. It will simply apply that function and result in creating the other partitions and another data frames. Okay, and these kind of transformations are known as narrow transformations, where no shuffling of data is required, where no communication between the partitions are required. Now there are functions, okay, when we use those functions, we need some communication between the partitions. Let's say this is your data. This is divided into two partition, p1 and p2. Okay, you performed one group by. Now you know, right? You cannot perform group by on a smaller set of data. You have to perform this group by an entire set of data, right? So you will, what Spark will do in memory, it will store the data from both the partition based on group by condition again. Okay, and then it will perform the group by operation on it, right? So the data is shuffled and the communication is required between the partitions, right? So whenever you see this kind of process flow of data, right, based on the functions, these functions are known as WideTransformation. Okay, another example is, let's say Spark created two partitions, okay, for your data p2, and we will see these examples in actual execution. Okay, this is your data. It created two partition, but now you are asking Spark to create three partitions. Okay, now what Spark will do, it will start putting some data from partition 1, some data from p2. Same goes with p2, this. So the data is shuffled, right, and then it will land to different partition. So whenever the shuffling is there from one partition to some other partition and some data into other partition, right, because we are dividing the data here, some data will go in p1, some data will go in p2. So whenever you see this type of division or this kind of shuffling, right, this is also a result of wide transformation, and we will see these kind of functions, right? So I think theory wise it looks fine, right? If I wanted to summarize it, I can say narrow transformations are independent processing of data within the partition, right? Because we are processing the data independently among between the partitions, right? There is no shuffling. But whenever we talk about the wide transformation, the data shuffling is there across the partitions, right? And there can be multiple ways of those shuffling. So let's switch over to the notebook. Okay, and let's, yeah, and we will see everything whatever we discussed in the practical example. Okay, so the first cell, again, it's talk about the imports which I have done, and the second cell where I am reading one CSV file. Okay, and while reading, I'm, as I told you earlier as well into previous videos, that read is a function which is an action function. Okay, so it will create a job, but on top of this I'm using one more option here, header equal to true. So what it says that my data includes the header as well. So the first row is the header of the file. So this will again result in creating one more job because it's an action for the Spark. Always remember, whenever you are passing the header equal to true or schema, right? Whenever you are saying uh, for infer schema, this will result in creating another job for you. So if I run this program, if I run this code, it will create two jobs for me. So job 1 and job 2. And as I said, every job will at least have one stage inside it. So you see the stages are created. And inside these stages, this one-on-one is known as task. So here what it says, out of one task, one is successful. Same goes in job 61 as well. So each job will have one stage inside it, and each stage will have one task at least inside it. Okay, this is what we discussed. Now let's move ahead. Let's perform some functions on top of it, or I can say some transformations on top of it. Okay, so I'd say df dot select, and I will select few columns. Let's say let's select only one column. If you want, let's select one more. So okay, so I have selected one more. I have performed one operation here, select, and then I am trying to display the data. Okay, and what we will see is it doesn't create any, it will not result in creating any stage here inside it. See, still we are getting one stage out of it. Let's go a little bit more forward further. Okay, now I will perform another operation. Let's say df equal to df dot filter. Okay, and I will say column, let's say period, and I want to check if the period is 2007. My bad, I can see from here. Okay, 2007 dot 12. Only this type of data I need where the period is this. Okay, so I wanted to perform this filter, and then on top of this I wanted to select only these two columns, and then I wanted to display my data, right? It's fine. This has some issue, this column needs to closed here. Okay, let's run it. So you see, again, only two jobs are there, and it doesn't result in any other stages as well. It means this is also a narrow transformation. So these type of functions are result, I mean, are known as narrow transformations. Okay, now before proceeding further, right, what I will do, I will check the number of partition which Spark created for this particular data frame. So to check the partition, I have to convert this data frame into RDD. Okay, get num partition. Once you create an RDD, then only you can find this function. Okay, and you can run it. It will give you the number of partitions which Spark created. So I didn't instructed anything to create the partition, but by default Spark created two partitions out of it. Okay, and we have seen after applying these operations as well, we are not making any change in the stages. Okay, so this is clear now that narrow transformations doesn't result in creating the stages. It is just the wider transformations. Okay, so only the wide transformations are result in creating the stages. Okay, let's go ahead with the wider transformations now. As I have talked, let's suppose we have two partitions. Now I want this data to be partitioned into three different partitions. Okay, let's see how does it result. We have dot repartition, and I'm saying I want to repartition data in four different partitions. Okay, and then let's perform some operations as well. Okay, so that it will be clear. So let's say select. Okay, then I wanted to do partition, and then I wanted to do one more operation. I just wanted to involve narrow as well as wide transformation to show you guys. df dot show. Now since I have used repartition, repartitions result in creating a stage because it's a wider transformation, right? Because we are doing shuffling, right? From two partitions we are shifting the data into four partitions, so there will be shuffling. So let's run it. See, it's creating time this time. It's taking time. And if you see, three jobs are created. Okay, because this results in creating a stage as well, which will be handled as a part of separate stage. Okay, so if you see, now we have two tasks inside it, but let's not go to the task. But if you see, in the last we have two stages created. So to understand it better how it actually works, now we will go ahead and see the DAG. Okay, because DAG will actually show you if the shuffling happened or not. Sorry, it's taking some time. Okay, so DAG visualization, and we are on the stage. Let's go to the job first. df.read, and one skip. This is skipped here. Let's move to this one. And if you see here, I will show you like how exactly I found out, right? I have to select that particular job, right? But you will see, my bad. You will see here 17th, right? I went to this particular stage to find out if there is a shuffling happened or not. So whenever shuffle happens, you see there are two stages created. Stage 69 and then stage 70. Yes. So now you see there is shuffling, right? So whenever you see any kind of shuffling happens, you will see read exchange will be created and write exchange will be created. So this is your exchange, right? So in term of PySpark, right, these shuffles are known as exchange of data, right? So the data is being exchanged between multiple partitions. Okay, now how to check if we are having four partitions now? Okay, so what I'll do, in the same code I will check df.rdd dot get num partitions. Let me check if it is showing somewhere. Let me print this. Let me remove this because it's creating confusion. So if you see here, we can see now there are four partitions for this data frame. So data frame being split into the four different partitions. Okay, so this is the difference, right? Basically, now and if you see here, because we ran this job after this action, right, we didn't perform any subsequent actions, so no stage will be created for this particular piece of data or code, right? So once the action will be invoked, right, or once you see the data only, then only you will be able to see the stages among them, right? So that's how the stages and jobs will be created. Let me give you one more example. Okay, let's read this data. So why I'm giving you these examples, so that it will be clear to you guys, right? df dot group by. Group by is again an example of wide partition, oh sorry, wide transformation. Okay, I'm saying I want to group by based on number of periods, let's say. Okay, group by periods dot count, and then I will store this in data frame, and I will do these kind of operations as well in between, just to show you again that that doesn't result in any transformation or any. So in this example also, if you see, I'm doing a group by, then I'm performing, I'm doing some narrow transformation as well, and then at the end I'm saying show my data. So if I run this, okay, show results, you see there are 3 jobs created. Okay, and this job will always again have a shuffle inside it. So let's see, go back to the job, and you can select the latest job description from here, and it will show you the DAG. So you see the exchange is there, right? So this is how the wide transformation and narrow transformation works, right? Based on the data is being processed during our execution. Okay, so I hope this will give you a good understanding of narrow and wide transformations. So thank you, thanks for watching this video.